Hey everybody, welcome back to the channel. So today's video is going to be kind of like a viewer request type of video where I have recently put out a couple of videos of me working on old Magnetos, and anytime I do that I have my Magneto Tester, which I will show you right here. And anytime I put together a video with this Magneto Tester, I always get people asking questions about where I got it. And the answer to that is, well, actually, I made that. This is something that I put together after, well, so the story is me and my dad, we have always worked on a lot of old tractors together. And one of the challenges that I'm sure anybody watching this channel is familiar with is, why is my tractor not running well? Is it fuel? Is it spark? Is it just the engine is old and tired? And so with the Magneto question, the spark question, there's nobody around here in our local area who worked on Magnetos. There's a couple of good shops that, can rebuild generators and test starters and do that type of, voltage regulators. They've also rebuilt a couple of voltage regulators for me, but they don't work on Magnetos. And we weren't really interested in having to send away, pay a bunch of money each time we wanted to send away a Magneto and then pay a bunch of money again to have it rebuilt, when we really didn't even know if that was the problem. So I looked at buying a tester, and they're hard to find. They're expensive, and lots of times they're really big, like ex-military jobs from World War II. They run off of like 3-phase power. They're made for testing a Magneto from like a big old aircraft rather than a tractor. So it just didn't seem feasible to try to buy one of those, spend the money on that. And I figured I could probably make one of these. So I got online and I started looking around at pictures of old Magneto testers. And so I basically, from pictures I saw online, I put together this Magneto tester. I will put the video or the drawings for all of the parts of this Magneto tester that I designed. I'll put those at the end of this video. And if you are interested in trying to build a Magneto tester, feel free to use the drawings that I have as kind of blueprints of your own. But I would encourage you to also kind of look at ways to kind of adapt whatever I have and make it work for you. So anyway, enough talking. Let me show you what I've got. So I've got the Magneto tester flipped around. This is the back side. And this right here is the very first thing that I had. This is the lifeblood of the Magneto tester. This is a little DC motor, and this is what I designed everything around because I had this. My brother actually gave this to me. It's a ball door DC motor. It's really small. It's probably undersized. It's 0.17 horsepower, if you can read right there. But it has this worm drive unit on the front, which kind of gears it down and gives you a little bit more power. But anyway, this is what I had. And so I designed everything around this, and it works pretty well. If I did it again, I would probably buy a little bit of a larger motor, but I do like having a DC motor because it gives you a lot of options when it comes to variable speed. So that's the very first thing I've got. So this is the base frame that I use, and I decided to use this 80/20 extruded aluminum, like T-slot channel. I don't know how familiar people are with this, but if you go to into any sort of like test lab or anything like that, this stuff can be used to build anything. Just go to Google Images and search 80/20 aluminum extrusion, and you will see the endless uses and the versatility that this channel or T-slot channel, whatever you want to call it, the versatility that it has. Okay, now with that spun around, you can see the front side of the Magneto tester. This is the spark gap. This is where I have all of my leads going to, and it's all adjustable. The reason this was probably one of the hardest things to find information on when I was trying to build this. It's obvious that, you need to have a positive terminal and a negative terminal on your spark gap. This one just goes to ground. All of these bottom ones are connected via kind of a bus bar. Let me show you on the back side here. Right here, everything's grounded with that. And so all of these lower terminals on each spark gap are grounded. But this third electrode was always a puzzler to me. And I searched and I searched and I searched. And finally, in one old document, I found someone saying that there is a third electrode in the spark gap that is supposed to be, let me adjust it over here. It's supposed to be kind of right over there next to the tip of this positive electrode. And its purpose, in the paper that I was reading, in the paper that I was reading, it described this as an isolated electrode. So it's not hooked to anything. And if you look on the back, sure enough, this isolated electrode right here is just on the back. It's not connected to ground or to the positive. And in the paper I read, it said that isolated electrode's job was to help ionize the air inside of the spark gap to help consistency with sparking and things like that. I put these in and I don't even use them because they kind of get in the way and I don't know. So if you were trying to build your own, I would say don't mess around. You probably don't need to mess around with the third gap. That's my experience. If there is an expert out there, please chime in the comments below and tell me what the purpose or if there is a benefit to having that isolated electrode inside of your spark gap setup. So, but the way that I set this up, this is just a piece of Delran, so it's an insulator, so it's Delran plastic on the backside, and all of these are just a bunch of hex-shaped standoffs that I just bought on McMaster-Carr, and then I just have some thumb screws that go in and out to hold the electrodes. Speaking of the electrodes, these are just pieces of TIG welding rod. They're tungsten TIG welding electrode. And I just bought a bunch of those and I sharpened them up just kind of crudely, but I sharpened them and they do a really good job. They don't wear down. They handle spark just fine. I mean, that's what they're built for, is TIG welding. So that's what I used there. And so I think that's been a good design. And the other thing is, you can see that I'm only set up to do four sparks, or four terminals at a time on a distributor or on a magneto. If I did this again, I would probably extend out to 6. I don't really see a purpose of going all the way to 8, but if I had 6, then I could also work on 6-cylinder magnetos a little bit more easily. If I actually can use these isolated electrodes right here, and I can flip them around, and I've used these as number 5 and 6 in the past, but if I was building this again, I would do 6, enough to test 6 sparks at the same time. This is the, I guess my flange adapter plate, I guess. This is what mounts the magneto. And I have this one, which is for a flange mount, or a flange mount style magneto, like this Wyco C right here. It's kind of a universal fit. I say kind of because there are some flange mount magnetos that do not have the same size and do not adapt to this very well. I'll show you some of those magnetos. And then the other style of magneto support that I built was this kind of base mount type of magneto. And I can take those two Allen bolts out, and I can put this base mount magneto right in place, just like that. And I can also test a base mount magneto. Let me go grab a couple of magnetos and I'll show you some of the positives and negatives that I've found with the current setup that I have. Okay, I went and I grabbed just a couple of examples of magnetos and things like that, showing just the versatility that this tester has proven to have. I can, like, here's an Oliver magneto from an Oliver 70. It's a flange mount. This works just fine. This is a short lug style magneto, and it bolts right up to this flange, no problem. And it doesn't matter if it's this, like I say, this American Bosch 6-cylinder magneto. I've got, this is a Farmall magneto from a Farmall Cub. So this is a J, I think it's a J style magneto. J4, I think. J4, yeah. So it's a J4 magneto. This is from a Farmall Cub. So it's different, completely different manufacturer, but it has nearly about the same interface. It mounts right up to here and solidly mounts in place. Works great. This is my favorite magneto. As you've heard me say, this is a Wyco XH magneto, and it just fits right up in place. Whether it's a short lug or a long lug, they both mount up the same. I guess I can talk about the drive coupling here that I built in a little bit. This is what lets you test long lug or short lug. I've got a couple of, these are Edison Splitdorf magnetos for an Alice Chalmers. This is a Delco Remy distributor off of a John Deere G, and even though it is a distributor, this still fits right up just perfectly, you know, no problem. It fits right in place. Very easy to test that as well. This is a giant base mount magneto that I mentioned that I can test, and I'll show you I can get this on the tester and I can show you that this has spark and it, you know, you can do all of that. But I went through the hassle of building this base plate or base support for a base mount magneto like this, and I've only used it like a couple of times. So unless you really need to have a base plate or a base mount magneto, you wouldn't even need to worry about that. You'll probably just be fine using a flange mount support like this. Where it does fall short is when you have, this is a magneto, it's a Wyco C magneto off of a John Deere LA. And as you can see, not only does it have a gear on it, which gets in the way. If you take this gear off, then there are some similar looking lugs. So you can remove the gear and adapt it to this drive collar right here, and it does okay. The problem is, I wish I could show you, the diameter of this ring right here is just probably about a quarter of an inch, maybe 3/16 of an inch smaller than these normal flange mount magnetos. Let me get my calipers and I'll show you. Okay, so I've got this is a Wyco C magneto, and the diameter of that flange on that, or the diameter of this lip on that flange is about 3.23 inches. Now, if I bring this over, this is that magneto off of the LA magneto, and as you can see, it is what? You can see that? 3.10 inches. So it's a little bit smaller, not a big deal. I've been able to work around that issue for the few times that I've needed to rebuild a magneto for an LA. So so that's just kind of something that you might want to take into consideration when you're building a Magneto tester, or if you're looking at building something like this. Just adapt it for whatever you think you will be testing the most. I apologize, that was a little bit long-winded. So this right here, this is the drive collar. I can pop this off. This is, I think, kind of one of the better parts of the design as well too. So coming off of the motor back here, I have a large pulley to gear it down to this small little pulley right here on this 1-inch shaft. And the reason I used a 1-inch shaft, I could have used, I mean, this is definitely overkill, but the reason I used that 1-inch shaft is because the center of this drive flange right here, or this drive collar, I needed to fit over the nut on that Magneto. You see? So I needed the center of that shaft to be larger than this nut on the backside of a Magneto. And I think that, what is that, 11/16 or something like that? I can't remember off the top of my head, but so that's why I used a 1-inch shaft. So I bought a 1-inch shaft on eBay, and then I designed this drive collar just to, like I say, to have the diameter here big enough to fit over the nut on the backside of a Magneto. But then this is just basically the notches right here just mimic the notches that are on your tractor, the drive lugs of your, on like a John Deere. This would be coming out of the right hand side of your governor. So that's all this is. And it just slides on this shaft, and it has a big set screw that's down in there, big beefy set screw, and it just goes over the keyway in this shaft right here, sorry. And then I can tighten that down. And like I mentioned, whether I'm testing a long lug or a short lug Magneto, I can adjust this in and out. And these pillow blocks right here that hold the bearings, they have like a cam lock on them, and so I can unlock those cams, and I can actually move this shaft in and out as much as I need to as well. So I've got a lot of adjustability there. But like I say, this I was pretty pleased when I came up with this concept, and it works really well. I can just move it out right into the lugs of the Magneto, tighten down that set screw on the backside, and this just does a great job driving the Magneto. I have this other drive lug that I built because some Magnetos that I was looking at pictures of, like this one for example, right here, has a female style of drive lug. So if I want to test this one, I need to have the opposite gender of drive lug. So yeah, so that's what this is, and this is just some tools key material that is fastened down in here through some set screws. So that's kind of how that's set up, and it works good. But I very rarely have ever used that. Pretty much everything I test has the same male style drive lugs like we got right there. Now, the very last thing is the DC motor controller that I built. So with the DC motor back here, you have to have a way to convert your AC power right here coming out of your wall to just a DC current to drive your motor. So with that plugged in, I just realized I also failed to mention in this little motor controller that I have, then there is this digital tachometer, and how that works is on this, it just has a Hall effect sensor that's wired up to it, and if you look right here, then there is a magnet mounted in this collar, and every time that magnet passes the Hall effect sensor, then it sends an impulse to this tachometer, and however many impulses a minute is however many RPM it's running. So that's what this is, and it's kind of nice to have just to kind of give you an idea of what sort of speed you're running. But anyway, with this digital motor, excuse me, with that motor control, the DC motor controller, then I have a, there's a circuit card back here. This is actually a commercially available DC motor controller, a variable speed DC motor controller. This is the box for the DC motor controller, that, excuse me, that circuit card that I bought. Oh, you're right here. This might be useful information. That's the model number and things like that. This is what I purchased for running my motor. If you have a different motor, obviously you might want to get a different controller, but this seems to work okay. I think this is probably 50 or 60 bucks. I can't remember for sure. And then I just mounted it inside of this little box that I purchased, and mounted everything and crammed everything inside of this. And right now, I should put in a double throw toggle switch so that then I can run really easily clockwise or counterclockwise. Just because if you have a counterclockwise magneto like a John Deere magneto right here, and then you want to test a clockwise rotating magneto like an Alice Chalmers or a Oliver or a International, then rather than having just a really easy double throw toggle switch, then I do have to go in here and I just have to change these two wires from the positive and negatives, and that just switches the direction that the DC motor spins. The speed of it is controlled really easily with this potentiometer, and so if I turn it on, I can slow it down, go nice and slow, and if I turn it all the way down, then the motor will obviously stop. But you can hear how the motor controller kind of shuts the power on and off gradually. So that's why I like having that variable speed DC motor controller that I purchased. Anyway, turn the speed up. That's going to be 500 RPM, 600 RPM, whatever you want. And yeah, it does a really good job spinning the magneto and letting me test whatever I want. So, let me shut that off. So anyway, hopefully you find that useful. Honestly, if you're just wanting to test a couple of your magnetos, you could probably get by just fine with setting your magneto in a vise. This is actually a useful trick. Let me show you this. So I'll show you here on this Wyco C magneto. If you hold the magneto as it is mounted on the tractor and try to spin the drive lug right here, you can see that the dogs right here, they hit that stop plate right there, and that's what controls your impulse. And so if you were wanting to do some testing with just a drill, just holding this in your bench, that right there can cause a big problem. However, if you just turn your magneto upside down, look at that, then those dogs don't ever fall into place. Right side up, they fall in place. And then it makes it hard. You have to overcome that impulse if you want to start testing it. But if you just turn it upside down, then you can spin this really easily and everything is going to work just fine, and you don't have to worry about overcoming that impulse. So that's just a little tip if you do want to do some testing in your garage. So anyway, hopefully that was interesting. Hopefully you picked up a couple of ideas of how you guys can do this in yourselves if you want to. I really want to try to put as much information out there as I can, because I know that when I was building this, I would have appreciated, seeing what other people had done. So with that said, thank you so much for watching, you guys. It's really fun to know that whatever I'm doing here in my garage, that there's people out there across the United States, out there across the world, who also find this stuff interesting. So actually, before I end the video, I do need to put plug in. I'll put those drawings here at the end of this video, and anybody who wants, take a look at those, copy them, do whatever you want. I hope that it's beneficial. Hope you find it useful, but really you will need to adapt it for whatever you're going to be doing. So the things that I will show you, let me flip this around. Really, the key things that you'll want that I'm putting the blueprints out there for are this flange mount support, and also this drive lug, and then also I will put I'll see if I can put in just kind of the dimensions of this spark gap, so that then if people wanted to build this, then they could. So there. With that said, I really will see you guys next week with another video.